Hey everybody, Unit 4, Lesson 6. Spelled circles right today. Check it out. Really good at spelling. Objectives for today are going to be to determine angles and segment lengths within triangles using its mid-segment properties, and the same within trapezoids. So let's get it started. Alright, so let's start with a mid-segment in a triangle. So in order to draw the three mid-segments, there are three of them in a triangle. Okay, this thing called a mid-segment, first we have to find the midpoint of each of the sides. So let's call that the midpoint there, and this red point. Now let's find the midpoint of this side. Okay, let's not assume that any one of the three sides is congruent in length. And then let's go with the green point here. That's kind of interesting. Maybe not the best choice, but it's all right. All right, now the three mid segments are going to be these three black segments connecting the red, the blue, and the green points. These are the three mid segments. Okay, so some interesting properties here that arise. The segment connecting these 2 points, let's call this A here and B here. That segment there is going to be parallel to the segment connecting the red and blue. It's also going to be twice the length. So you can see the distance from A to the green point is going to be the same as the distance from from the red point to the blue. Okay, this length here is going to be the same as that length there. Okay, not to mention there's a bunch of angle properties that are present too, but we'll get to that in a minute. The length here from the red to the green will be the same as from here to here, or 1/2 of the length from, let's call this C to B. Okay, so this length we would mark with 2 markings. And of course, the green to blue point we would mark with 1 marking. So it creates some very interesting properties with regards to angles. Okay, if these 2 segments from A to B and red to blue are parallel, then we got a bunch of angle properties. These 2 angles would be the same. Okay, and likewise, these 2 angles would be the same. Okay, those would be corresponding angles. Okay, likewise here, if B to C is parallel to green to red, then the following would be true. This angle would be the same as this angle, corresponding angles. And the angle located here at angle B would be the same as this angle located here, also by corresponding angles. Okay, and then if we ended up using, the other parallel lines conjecture with AC and green to blue, we would see that there'd be a very similar relationship right there. So now look at these 3 triangles, 1 and 2 and 3. Those are all the exact same triangle shifted. So if I took this triangle and just shifted it up and to the right, it would match perfectly, provided I found the exact midpoint of those sides and then brought it down here, shifted it. Perfect. There we go. Now within any one of these triangles, you'll see I have an angle with 1 marking, 2 markings, and 3 markings. That means those 3 angles are supplementary. So if I look at these 3 angles, here's one with 1 marking, one with 2 markings, and an unmarked angle. That's going to take on the same angle measure as we see up here, an angle C. So you can see this angle here and this angle here, same number of markings. Likewise, right here I'll have a marking of 1. That'll be the same as this angle. And likewise, angle A's measure will be duplicated right here. So you see that a mid-segment, or in this case 3 mid-segments, creates 4 congruent triangles. It's pretty interesting. We're going to see those properties arise here in a few moments in an example. All right, so take a look at this example here. I've got a bunch of measurements. I can clearly see, I'm looking for X, and I'm looking for Y, and I'm looking for Z. Those are all side lengths. I can compare those to the side lengths that are given, right? So I can see clearly here that Z would be 13. I can see that X would be 14, and I can see that Y would be 15. Okay, now when it comes to angle measures, I'm looking for angle measures A, B, and C. Okay, well I could see based on the properties that we saw in the last slide that this angle, which is 40, will be the same as this angle and this angle as well as that. So C will be 40. This angle here that's 45 will be the same as this angle and this angle and this angle. So A would be 45. And finally, based on the fact that I've got these three mid-segments, right? The only reason I can make these assumptions is because these three line segments here are mid-segments, right? They're connecting to vertices which are midpoints of each of the sides of the triangle. That's the assumption being made. So clearly, angle B will be 95. Okay, let's look at a few more examples. Now what's cool is that we'll be able to see, let's look at how the mid-segments kind of take shape in different types of triangles. So let's take this equilateral triangle and let's find the midpoint of each side. Now in an equilateral triangle, if the sides are all the same, then the midpoints will separate the sides into 6 equal lengths. So when I connect these with the mid-segments, again, these are the mid-segments, these red lengths, we'll get 4 smaller equilateral triangles. And it's kind of cool. You can see that each of these equilateral triangles, I'll name them 1, 2, 3, and 4. They're each 1/4 of the area of the original, but 1/2 of the perimeter of the original. It's kind of cool. All right, let's look at an example of a right triangle. Okay, of course, here's my right angle. We can see that clearly. Find the mid-segment of the shortest side, or the midpoint of the shortest side. How about the midpoint of the next leg and the midpoint of the hypotenuse? When I connect these with the 3 mid-segments, 1 and 2 and 3, I get 4 right triangles. And notice I've got this angle marked here, this angle marked here. I'm going to appropriately distribute those angles as such. Oops, I messed one up. That was a fail. Oh, actually, no, that one was right. What did I goof up? This one. Here we go. There we go. Perfect. Got it. Okay, so you can see that I've got 4 congruent right triangles. It's cool how it duplicates. Okay, let's continue. All right, now let's look at the properties of the mid-segment of a trapezoid. Okay, a trapezoid has only one mid-segment. One in a trapezoid. Okay, so here is my mid-segment connecting these 2 points. These 2 points are midpoints of those sides. I can tell by the markings. So the mid-segment connects those 2 points. There's only one of them. That mid-segment is parallel to the 2 bases. Okay, it's parallel to the 2 bases. What it does is it splits this into 2 trapezoids, which have, interestingly enough, base angles congruent. Now, those trapezoids are not the same size. They're not. However, there are some interesting properties that arise within that. We're going to look at those on the next example. Okay, but you can see that these base angles here are congruent to these base angles here, and these base angles here congruent to those above. Okay, and that's based on the fact that we've got these 3 parallel lines formed because of the mid-segment that cuts from midpoint to non-base to the opposite non-base sides. Okay, let's look at some examples on the next slide. Okay, let's look at this first example here. It says fill in the missing angles and sides and find the perimeter. Okay, so I'm able to, just based on how this looks, I see this marking here. this marking here. I know this will be 3 centimeters. And then I see the same on the other side, so this will be 4 centimeters. Now, if I want the perimeter, I can just add up 14, which is the base on the top, 24 base on the bottom, plus 2 3s and 2 4s. This will equal the perimeter of the trapezoid. So I'll get, oh boy, what would that be? 14, and 14 is 28. So 28 and 24 is 52. So I'm getting a perimeter of 52 centimeters. Okay, now let's talk about angles here. Again, midsegment creates base angles, in this case, that are congruent. So A would equal 60 and B would equal 70. Now in the previous slide I said all 4 of these angles would be the same, and that's true in that case, but in this case it's not, because this side and this side are not the same. Okay. Likewise, I can mark these 2 congruent. And the cool thing that I know in trapezoids is that in this case A and D would be supplementary. That would make D 120 degrees. 120 degrees. Okay, likewise, I can see on the other side that B and C would be supplementary. Therefore, since B is 70, C would have to be 110. Right? They'd have to add up to 180. Now, this is the cool part about midsegments. Right? Because this length here, this blue length, is a midsegment. Right? That means that 14 and X and 24 have a special relationship. Okay? It means that X is the midpoint of these 2 values, 14 and 24. Okay? That means that 14 plus 24 divided by 2 is equal to X. That means 14 plus 24, which is 38, is equal to 2 X's, and thus X is equal to 19. Now, another way that you can visualize this is that whatever the change is to get from 14 to 24, right, which is 10, then the change from 14 to X and the change from X to 24 would be the same. Therefore, I would add 5 to 14, which of course would give me 19, and 19 plus 5 is also 24. So X is kind of like the midpoint of 14 and 24, which again only happens because of the midsegment property here. Okay, pause the video if you'd like to continue to work without my instruction. Come back and revisit. Okay, so now look at this. I've got all these segments are the same. That means that my base angles on the lower end will all be the same. They'll all be 62. Therefore, Y is 62 degrees. Okay, now I know Y and Z, those 2 have to add up to 180. Therefore, I'm going to have 118 degrees for Z. Okay, now I'm done with figuring out angle measures. Let's talk about side lengths. Okay, now, when we looked at the side lengths, again, we said that X and 26 add up and divide by 2 to give me my midsegment length. Therefore, X plus 26 divided by 2 is equal to 15. Right? Or you could think of this as X plus something equals 15, 15 plus something equals 26. X plus 26 then would equal 30, therefore X would equal 4. Now you could solve it using that midpoint formula, or you could see that I added 11 to go from 15 to 26. Therefore, if I add 11 to X, then I would get 15. Thus, X would have to equal 4. Now the perimeter, of course, I need X in order to find. It looks like I've got 6 4 times, and I've got 4 once, so I've got 4 6s. I've got a side of 4, and I've got a side of 26. This will equal my perimeter. So 24 plus 4 plus 26. Looks like my perimeter will equal 54. All right, let's look at one more example here. Let's look at this triangle right here. Okay, looks like I've got 3 midsegments. Let me get in here. There we go. The mid-segments would be the following. I'm just going to sketch them in blue. And I know they're the mid-segments again because I see that E is the midpoint of FD, I see C as the midpoint of AD, and I see B as the midpoint of AF. Okay, I can see based on the markings that this will be 11 centimeters. This will be 10 centimeters, and because this side length here marked in red is 12 centimeters, these will also be 12 centimeters. So the perimeter, which it's asking us for in this question, of ADF, right, let's highlight ADF, oops, A to D to F. This triangle, the perimeter of that triangle, will be 2 10s plus 2 11s plus 2 12s, or if it makes the math easier, 2 of these, 10 plus 11 plus 12, which of course will be 33 times 2, which will be 66 centimeters. Okay guys, that's it for today's lesson. That is lesson 6 on mid segments. We'll see you in the next video.